Alright guys, welcome back. Video 2 here for exponents. Today what we're going to do is kind of stem off of our last video talking about condensing and expanding exponents. Today we're going to hopefully take some of the things we learned from last video and make some rules. So let's take a look first. Alright, first rule we're going to talk about is called the product rule. So the product rule, again you got to think, what does that mean? Product means mathematically multiplication. So product rule, here's kind of the fancy way of looking at it. All right, is when you multiply two things, two numbers with the same base that have different powers. So for example, down here, here's a good example to show you what I mean. I have two of the same base, so 2 and 2 same base, different powers. So what happens when I multiply these together? So remember, we kind of talked about expanding. We did the whole video on expanding these. Remember, 2 squared means 2 times 2. 2 to the fourth means 2 times 2 times 2 times 2. So in total, when we expand it, condense back down, we look at, okay, I have 6 2's here, so I can also rewrite this as 2 to the 6. So some of you may have seen this already or kind of noticed this as we went through the last video. We can break this down and simplify it into a rule. Notice here, I have a power of 2, a power of 4, and I give you 6 as a result. So what rule can we have here for the exponents? Well, when we have the product rule, what we're going to do is we are going to add our exponents together. So that means we can simplify the work. Do we need to expand and condense the whole time? No. We see a problem where we can apply the product rule. What we can do is just simply add the exponents together. This is only true if we have the same base, and that is important. So make sure you write that down. That's an important thing. Must have the same base. So let's look through some examples. First one, I have 8 to the 5th times 8 to the 3rd. So these ones, again, notice same base. Bases are both 8. So what I can do is just simply take this, add the exponents, so 5 plus 3, what would that give me? 8 to the 8th power. That would be my final answer. Makes it a lot simpler, don't you think, instead of expanding and condensing back down? Next one, we have y to the 9th, parentheses, y. So what does that mean again? This means y to the 9th times y. Well, what's the power there? It's y to the 1st power. Just y is y to the 1st. So applying our rule, we're multiplying same base of y, so I can just take these exponents and add them together. 9 plus 1 is going to give me y to the 10th power. That's my answer. Okay. Next one, we have three things. We have a to the 4th power, a to the 3rd power, a to the 10th power. So we have three things multiplied together instead of two. Well, remember, multiplication, it doesn't matter how many things I multiply together as long as multiplication, for example, I can do 2 times 3 times 2, I can do that in any order. I could do 3 times 2 times 2. It should give you the same result in the end. So now looking at this one, I have a, same base in all three of them. I can add all the exponents. So 4 plus 3 plus 10, what is that going to give me? That is going to give me a to the 17th power. Okay, so add all the bases. All right, next one, last one, a little trickier here. We have 2x to the 4th power times 3x to the 5th power. Again, we have x to the 4th, x to the 5th. Now notice here difference. I have numbers, 2 and 3. Well, here's a rule for you. Treat numbers, that's our number symbol, not a hashtag, like numbers. So what does this really mean? Well, this means I'm taking 2 times 3, and then I'm going to have x to the 4th times x to the 5th. I'm going to treat my numbers like numbers. So what's 2 times 3? Well, that's 6. Okay, x to the 4th, x to the 5th. We're going to take our same base of x, add the exponents together to give you 9. So that simplifies out to 6x to the 9th. So again, here simplifying, don't need to expand and condense, just using my product rule to figure out what the final power would be. All right, next one, we have the power rule. So power rule, product meant that we took two things and multiplied together. So power, what this means, power, think of that as an exponent. So what we have here is another exponent being applied to an exponent. So for example, a to the m to the nth power. This is kind of some sassy math jargon on how we actually write out the rule, but let me give you an example. Could be x squared, and that x squared is taken to the 4th power. Okay, so again, last video we talked about expanding. Let's expand this one. X squared to the 4th power means I'm going to take my base, which is inside the parentheses here, x squared, and to the 4th power means I'm going to take x squared times itself 4 times. Well, let's see what happens. And if I expand each of these, that's x times x, x times x, x times x, x times x. How many x's do I have in the end? 1, 2, 3, 4, 5, 6, 7, 8. So as a result, I am going to get x to the 8th power. Okay? So let's take a look at exponents here. Let's see if we can come up with our rules. Some, again, you might have noticed this in the last video. My power of 2, my power of 4. Okay, so the last one we looked at, okay, the product rule that they added together. Well, let's think, how do we get from 2 and 4 and we get 8 as a result? Well, 2 times 4 is 8. So here, we're multiplying. So our rule here is that when you have the power rule, you are going to multiply the powers together. So the powers are going to multiply. Okay, so let's take a look at some examples. First one, let's do x to the, or sorry, not x, 7 to the 4th power taken to the 3rd power. So again, I can just apply, instead of expanding and condensing, I can apply my rule. I'm going to take my powers. It's 7 to the 4 times 3 power. 4 times 3 is 12. So 7 to the 12th power is my final answer. Again, a lot simpler. Then I have x to the 5th to the 2nd power. Again, I'm going to apply my rule that the power rule says I'm taking a power to a power. I'm going to multiply the powers together. So 5 times 2, that's going to give me x to the 10th power. Okay, again, notice how simple this is once we get the rules down. Okay, next one, now we have negative 10x to the 6th power taken to the 2nd power. Now you have to think, this one's a little different here. Okay, we have negative 10x to the 6th power. So we have a number and a variable inside. So just like I said the last slide, hey, treat numbers like numbers. So when I see this, really what this is going to end up being is negative 10 squared. Not only am I going to square the number, but I'm also going to take the variable x to the 6 and square that too. Okay? I like to think of it as distributing a power. You know, remember we did distributing when it was 2 times or something times something in parentheses? It's the same idea here. Okay, but we're distributing a power instead of just a number. So now we simplify 10 squared, negative 10 squared, that's 100. X to the 6 to the 2nd power, now we can apply our rule. Okay, so x to the 6 second, we're going to multiply our 2 powers together. 6 times 2 gives me 12. Okay, so 100x to the 12th. So again, treat numbers like numbers. Okay, now the next one, we got a fraction in here. Don't freak out. Notice this one, we got a lot of sass. We got a fraction, we got x, we got y to the 3rd. Let's apply our rule. Okay, so let's again treat numbers like numbers. So this really means 1/3 to the 2nd power x. I'll put parentheses around it to the 2nd power, and y to the 3rd to the 2nd power. Okay, now what's 1/3 to the 2nd power? You know what? Just for you guys, let's leave that just as is. Okay, let's not simplify that fraction, but let's worry about the variables. Now we have x to the 2nd power. Well, that really is x to the 1st to the 2nd power. So 1 times 2, that's going to give me 2. So that's x to the 2nd power. Y to the 3rd, notice here I have 3 and a 2, so I am going to multiply those. That's going to give me y to the 6th power, and that would be my final answer. Again, we could simplify 1/3 to the 2nd power, but we'll leave that as is for now. Okay, so this is the power rule. We're taking a power to a power. What we do is we're going to multiply the 2 exponents together. All right, last rule we're going to talk about here is what's called the quotient rule. So the quotient rule, what we are going to look at is what happens when we divide. So again, think back, quotient is a fancy math term for divide. So what happens when we divide two things that have a power? So again, here's the fancy math jargon. We have a to the m divided by a to the n. So again, here notice a, same base, different powers, but I'm dividing them. So what do we notice? Well, I kind of have the rule written down, but let's take an example of 2 to the 5th over 2 to the 3rd. So let's expand this. That means 2 times 2 times 2 times 2 times 2. I think that was 5. And then we have 3 of them on the bottom. So again, what happens when we divide? Cancel out. So we get 3 of the 2's to cancel out, and we're left with 2 to the 2nd power. So let's take a look. We have a 5. We have a 3. We end with a power of 2. How do you get from 5 to 3 to equal 2? You subtract. So the quotient rule here is when we are dividing things out, we need to subtract exponents. Okay, I'll write as the XP. Subtract exponents. What else do you notice here? The important thing, like we did with the product rule. Notice here, base of 2, base of 2. So what rule do I also need to apply, or what do I also need to make sure I have is the same base. Okay, so I want the same base when I look at this rule as well. So product rule, quotient rule, same base. Power rule doesn't make a difference. Okay, let's go through examples. First one, I have 2 to the 11th. Divide by 2 to the 6th. I'm going to do my power or my quotient rule. I'm going to divide. So that's going to be 2 to the 11 minus 6. 11 minus 6 is 5. That's 2 to the 5th power. Again, I could simplify that, but we'll leave it. Okay, negative 4 to the 7th. Divide by negative 4 to the 4th. Okay, base. Notice same base of negative 4. We're good to go there. Negative 4 is my base. Power is 7 minus 4. Again, we taking a quotient, same base. Subtract the 2. That's going to give me negative 4 to the 3rd power. Final answer. Okay. I forgot to write these down and kind of just said it. Notice here base is 2. Base is negative 4. Let's take a look at the second one. Now, we have a variable there. But notice x to the 5th, x to the 3rd. Notice we have the same base here. We have a base of x. So we're set to go. They have the same base. That means we're going to take our base x, and we're going to take it to the 5, and we're going to take the powers and subtract. 5 minus 3, that's going to give me x to the 2nd power. That is my final answer. So key thing here, notice here, I kind of skipped through it a little bit, but we got to make sure we have the same base when we apply both this rule and the product rule. Okay, I have 2 examples on the bottom. These are tougher ones. I want to give you guys a little challenge. I want you to pause the video right now, and I want you to see if you can answer these ones. Okay, 3y to the 11th, and we have 12y to the 5th, and then we have a whole mess on that bottom right. Okay, again, think base, base, base. Here we go. Give it a shot. Pause. All right, let's see what you got. Now, I threw some extra sass at you. First of all, first example, notice numbers. We have 3 over 12. Don't forget, I put it here. Treat numbers like numbers, okay? So when I see 3 over 12, I don't want to get confused because we're doing exponents, but 3 over 12, I can simplify that to 1 over 4. Okay, that simplifies, and then I treat the variables like that with the powers. Y to the 11th and 5th, I'm going to subtract those. And I get 1/4 y to the 6th. Okay, so a lot simpler than you look. This one, holy cow, looks like a hot mess, but actually is a lot easier than it seems. Again, treat numbers like numbers. I have 6 and 2. 6 over 2. What's 6 divided by 2? That's 3. Okay? Then I have x's. X to the 9th, x, well, just x by itself, that's x to the 1st. So what I'm going to do again, quotient rule, subtract. 9 minus 1, subtract the powers. It's going to give me x to the 8th. Y's, I have y to the 4th, y to the 2nd power, subtract those. 4 minus 2, that gives me y to the 2nd. Same thing with z, z to the 5th, z to the 4th. Subtract those, I get z to the 1st. That's my final answer. So again, using these rules, holy cow, we make life a lot simpler. No longer have to expand and then condense back down. Okay, here I got some more examples of the quotient rule, but notice here where you have, if you notice these top 3 examples, what do we notice? 2 and 3, x and y, 2x and y squared. We have different bases, and we have powers on the same thing. So with these ones, kind of similar because we are taking a quotient and raising it to some power. What do we do here if we have a situation like this where we have 2 over 3 to the 3rd power? Now notice in the last slide I kind of skipped over when we had 1/3 to the 2nd power. Why did I do that? Because I wanted to talk about it here. Okay? Basically what this is saying, 2 over 3 to the 3rd power, what it means is that is, you think about, let's expand this out, that's 2 over 3 times 2 over 3 times 2 over 3. Well, if you look at the numerator and denominator, take a look at the numerator, that's 2 times 2 times 2. Well, is that not 2 to the 3rd power? And the denominator, I have 3 times 3 times 3. Is that not 3 to the 3rd power? So what did I end up doing here? Well, basically what I did is I took this exponent of 3 and I applied that to both the numerator and denominator. I distributed it. That's what I kind of like to think about. Distribute that power to the top and the bottom. So this I can simplify out to that. Okay? Let's see what we get here. Okay, again, think about distributing. I'm going to take that third, take x to the 3rd power, and apply that to the denominator, y to the 3rd. Okay, and I get that as a result, x to the 3rd, y to the 3rd. Okay, so again, I can distribute that thing just like I would before. Now, next one, again, I have 2x over y squared to the 3rd power. Okay, we can do the same thing here. Let's treat numbers like numbers. What that means, 2x to the 3rd. Again, I can expand it out, 2x, 2x, 2x. Numbers like numbers, I have 3 2's, so that'd be 2 to the 3rd power. X, x, and x, that'd be x to the 3rd power. So notice how I distribute that power to both the 2 and the x. And then y squared, you can think this one, y squared, y squared, y squared. I could expand that out. Y times y, y times y. How many y's do I have on the bottom? That's y to the 6th. So what rule did I apply here? Think about it. What rule did I apply? Okay, distributed that power there, and guess what? That's a power to a power. I use the power rule, and there I get my final answer right here. I got y to the 6th on the bottom using my power rule. Okay, I'm going to show you guys a little trick. Okay, down here, notice how I got some really complicated problems. Okay, really complicated problems that we have. Okay, with different variables, different things going on. So I'm going to show you some rules. Now, think back. I showed you guys this a while back. Order of operations. If you remember, order of operations. Now, I used parentheses, but you can use what's called grouping as well. But remember, order of operations. You're going to do parentheses first, or you're going to do all the groupings first. Then you're going to do the exponents, then multiplication, division, then adding and subtracting. Now, looking at this GEMDAS or PEMDAS, really this is a helpful way to remember how to apply the rules. Okay, so let's take a look at this first example, and I'm going to show you how this GEMDAS is going to help you to figure this out. Okay, here I have 5y to the 3rd times 6y to the 7th. So what am I doing here? Well, this is a product. Okay, so I'm going to do the product. I'm going to apply the product rule here. So what's the product rule? What does product mean? Product means multiplication. So multiplication is here. So what I'm going to show you is this. If I circle multiplication and what's below it. Multiplication, what's below it, the A? What does that stand for? Add. What does that tell me? Well, when I take my product rule and I multiply powers, I'm going to add the exponents together. Okay, so again, treat numbers like numbers. 5 times 6, sorry, I'll write this here. 5 times 6 would be 30. Then I'm going to take y to the 3rd, y to the 7th. Multiplying exponents, taking a product, I'm going to add, I get y to the 10th. Okay, so using this GEMDAS, you can actually give, it kind of shows you the rules. It kind of makes you remember it. Multiplication, add. Okay, next rule, what do we have? Well, we have a power rule. Power, right? Well, you have here power. What's really inside the powers? We have parentheses. So think parentheses is like grouping. Okay, grouping is parentheses. So when I group these, notice there I have a grouping. Outside the grouping, I have an exponent. So grouping an exponent, what am I going to do? Drop a gem on them, right? I am going to multiply. Grouping with an exponent is going to lead you to multiply the powers together. Okay? So what does that mean? Well, again, first of all, I'm going to treat numbers like numbers. I'm going to take 4 to the 4th power. I always like to, again, think this is distributing. It's going to be x to the 5th to the 4th power times y to the 3rd to the 4th power. Okay, so I group those together. I distribute the power. Now I'm going to use my rule. Okay, my rule for power to a power with the exponents is multiplication. So I have 4 to the 4th power, x to the 5 to the 4th, which is 20, and then y to 3 times 4, which is 12, and there's my final answer. Okay, so GEMDAS, notice here, grouping, exponents, you multiply. Okay, now let's take a look at this last example here. I have quotient. Quotient means to divide. So let's kind of do what we did the first problem, divide. What does that mean underneath? Divide, you subtract. Division, you subtract. So what I'm going to do is subtract my exponents. So here, again, treat numbers like numbers. 5 to the 7th, I can't simplify. A to the 8th over A to the 5th, that's going to be A to the 8 minus 5th. I subtract my exponents. And b to the 5 minus 3, subtract again, so I have 5 over 7, a to the 3rd, b to the 2nd, done. So again, I can use this kind of shortcut way of thinking about it, using my order of operations to think about what my process is. Okay, last example here. I want you to try this one on your own. This is, you see it, baby. Bring the pain, man. Look at this problem. Holy cow. Let's give this one a whirl. Again, I want you to use your rules of GEMDAS over here, or grouping, exponents, multiplication, division, adding and subtracting. See if you can figure this one out. Now, there's a lot of jargon going on. Okay, so let's get it done. So pause the video, give it a shot. All right, rock and roll. Okay, this is kind of like a puzzle. But let me show you quickly what I did. So I started with the top. The top is a big mess. So I want to clean this up first. Looking inside, I see grouping. I see groupings here and here. So I'm going to apply my grouping rule. But notice, only the first grouping has an exponent. So grouping, exponent, what am I going to do is I'm going to multiply my exponents together. So I applied the 3rd power to all 3 of these terms. 2 to the 3rd, a to the 9th, and then b to the 12th. So what I did is when I applied these, I multiplied the powers together. 3 times 3 is 9. 4 times 3 is 12. Okay, then I brought this one down here, 4ab to the 5th. No, there was no power outside, so that's fine. Then what I did is kind of rewrote things, okay? I wrote things all together, grouped my a's together, my b's together. Now what am I doing? A to the 9th times a, that's multiplication. That means I'm going to add my exponents. So I added 9 and 1 to give me 10, 12 and 5 to give me 17. Okay, I'm leaving the numbers for the end, but I still have these numbers here. Then I brought the denominator down. So notice the denominator brought it down here. 64, a to the 5th, b to the 3rd. Group these together shown in green. Green, I am dividing. That's my quotient rule, means I'm going to subtract. So I subtracted 10 minus 5 to give me 5, 17 minus 3 to give me 14. Then what I did here, folks, don't get lost here. I know I'm talking fast, but last thing I did was simplify the numbers. 2 to the 3rd power, 2 times 2 times 2 is 8. Multiply that by 4, I got 32. So the numerator up here becomes 32. Denominator 64. Well, 32 goes into itself once and into 64 twice. So this simplifies out to 1/2. A to the 5th, b to the 14th. Final answer. You stand up like a bouse and you flash the belt. Ready?